So, continuing with higher cognitive phenomena, finally, I'd like to have a quick look at three major domains. The first is intellectual skills, and I'm going to use arithmetic as a very simple example. The second is planning for the future, where I'm going to use tool making as an example. And thirdly, to discuss the question of human consciousness. Now, it's clear that the way we perform mental arithmetic has almost no resemblance to the way calculators or computers do it. And it's a significant effort for us to learn. Children take from age 5 to age 10 to become proficient, about as long as it takes to learn their native language. And even then, children and adults continue to make lots of mistakes. And our brains call upon lots of different ways to get to the same desired result. For small numbers, and especially when first learning, to determine the result of adding 4 plus 3, let's say, we may count up 3 numbers from 4, counting 4, 5, 6, 7. The answer is 7, perhaps even using our fingers. And a lot of effort goes into memorizing results like the multiplication tables. And we develop shortcuts, like adding 0 to the end of any number to get the result of multiplying it by 10. And sometimes we don't need an exact result, just roughly, like how many square feet of carpet do we need for a room 14.5 by 17.5? And some of us have learned to make quick estimates like 250, or something within, say, 10%, without needing to go through a detailed calculation. And we can quickly identify which is the larger or smaller number. So we have lots of alternative ways to handle the information we're given to arrive at a solution. And it's always possible for us to make lots of errors. And the process therefore seems very different from the algorithms used by a computer, for example. So if we want to understand the mental processes, the brain processes for handling mental arithmetic, we have to find some other approach, not the approach for using the algorithms that are performed on a computer. Human beings have considerable ability to plan for the future. And one example of this planning is tool making. Among animals, some tools, like spiders' webs for example, seem to be genetically programmed in detail. But about a dozen primate species and a couple of dozen species of birds, and also dolphins, seem able to learn to use available objects like sticks, rocks, or leaves, or in the case of dolphins, a sponge, as tools. So birds can use a stone to break open a shell. A smaller range of animals have been seen to modify something available on the spot to make a tool, like one species of crow that can bend a straight piece of wire to make a hook, and then use the hook to get food out of an inaccessible location. But the raw material, like the piece of wire, has to happen to be available when and where the tool is needed. The crow doesn't go looking for it. Chimpanzees modify sticks to be better at getting termites out of their nests to eat them. And sometimes they bring the sticks with them to the nest location. But they don't make the tool in advance, away from the location of the termites. Humans, on the other hand, can make tools well in advance and far away from where they'll be used, even in locations that have never been visited, like tools to work on the surface of Mars. So maybe the key difference with human tool making is the amount of information the brain can draw on that isn't actually present in the current environment. And the third area I want to talk about is consciousness. Now, the problem is that even the definition of consciousness is a source of a lot of confusion. If it's defined just to mean purposeful action, a bacteria can respond to a stimulus, detecting a chemical gradient and swimming in the right direction. If it's defined to mean the abilities to learn and communicate, insects and reptiles have those types of capabilities. Mammals and birds have the ability to plan, including tool-making in some cases, as we've just discussed. Humans experience a rich interior mental life. But of course, we can ask the question, do some animals experience something similar, or perhaps much simpler? But the key thing for scientific understanding is to avoid the idea that consciousness is some magic ingredient that somehow permeates life. What we want to do is find out how to describe conscious phenomena in terms of anatomy and physiology. First, we need to describe those phenomena at the cognitive level. And there are at least 4 cognitive phenomena that are generally regarded as being characteristic of human consciousness, plus the view that some cognitive phenomena are definitely outside of consciousness, or unconscious as it's expressed. Our day-to-day experience includes a constant stream of mental images and feelings that's often almost completely independent of our current sensory experience. Furthermore, this stream of mental images can include images of ourselves, behaving and experiencing in different ways. Then, there's the feeling that we can experience the same sensory input in different ways or to different degrees. We have the ability to verbally describe some, but not all of our experiences. And finally, sometimes we can be unaware of some things happening in our immediate environment, although in some cases our behavior is influenced by those things. So let's have a look at these phenomena in turn. If we were in, say, a lecture hall, we'd be getting direct visual input from the room. But in parallel with these direct visual images, there can be a stream of imaginary visual and verbal images going on in our heads. A bit like a movie, which may have a very weak connection with what we're actually seeing directly. It could be images connected with the content of the lecture, but it could also be something completely unrelated, like what we're going to do tonight. Our experience of this mental stream seems to be moments when the images or words are clear, separated by periods in which the images are much more vague or fuzzy. This mental stream can include images of ourselves. For example, as a member of the audience, we could imagine ourselves giving the talk. And perhaps most remarkably, conversations can take place between our current self and this mental self-image. The self-image can even suggest behaviors to the current self. Now, qualia is the name philosophers have applied to postulated units of conscious sensory experience, noting that sometimes we can have very vivid experiences of even, say, the colour red, and wondering about the nature of that experience. That was a tree. You saw it long enough to be able to name it. If you were out walking, that quick glance would be enough to avoid walking into it. But if you focus your attention on the tree, you can get a more vivid tree-related experience. But it's hard to describe this experience in words, beyond saying it's richer. Although it can initiate a stream of consciousness that, at least at the start, has to do with trees and which we can describe. And there are some cognitive questions we could ask about these richer experiences. For a given visual object, is the experience the same every time? Is it the same for different people? Why can't I describe its content in more detail? Now, in general, why are there some parts of our experience that we can't describe verbally, like how we perform skills? And sometimes things happen in our immediate environment that are completely outside our awareness. This is a picture from a famous video where a black shirt team of people and a white shirt team are tossing a ball around. If you are asked to count the number of passes between the white shirted players, and if this is the first time you've seen the video, you are quite likely to completely miss the person in the gorilla suit who openly parades through the players part-way through. If we're not paying attention, we can completely miss things. In this case, if your attention is focused on the ball and counting the passes, you miss the gorilla passing through. But sometimes these things we're not aware of can influence our behavior, and the classic experimental demonstration of this is called dichotic listening. In these experiments, a subject listens with earphones to texts being read out loud, with different, completely unrelated texts read to each ear. The subject is asked to pay attention to the text being read to one specific ear and to repeat that text out loud as it's being read, like the black dog chased the cat up the tree and the cat got stuck on a branch. The task isn't difficult, and afterwards the subject can remember the attended text, but not the other. So you might conclude that no information from the unattended text reaches the subject's brain. However, in the experiments, part-way through reading, the texts were suddenly switched between the ears. So in the attended ear, the subject heard, for example, the black dog chased the cat up the tree and the cat got business health. Now, despite the change between ears, the subjects continued to repeat the continuation of the text they'd been repeating. The cat got stuck on a branch, completely unaware that the final words were arriving in the other ear. Now, the significance of this result is that it implies that some information was getting to the brain from the unattended ear, enough to allow an instant switch when it became the meaningful continuation, despite having created no awareness or memory until the switch occurred. And a more everyday example of unconscious processing of information is the experience of driving a very familiar route and sometimes arriving at the destination and realize you've got no memory of the journey. Your thoughts have been elsewhere. So we've discussed a range of different human cognitive features. But these are the physical structures that perform all those features, and these are some of the types of neurons that carry out the information processes implementing the features. So what we're aiming to do is to understand the features in terms of the brain. But as a first step, we've got to learn a bit more about the physical brain, and that's what I'll be describing next.